Hello and welcome. This is part 2 of section 1.1, and in this video we'll look at sort of common mistakes or pitfalls we'll see when we're analyzing data. So after we've made a study and we have some data and we want to sort of understand it a little bit better, we'll analyze it, and there's a few things that, a few mistakes that people will quite often make. And one thing is we'll quite often make misleading conclusions for the following fact. We'll see that some data may be correlated, and we'll assume that they're correlated for a reason. And this is not always the case, and what I think is a great example. You can look at the number of pirates in the Caribbean. So the number of pirates in the Caribbean, and this has gone down over the last 200 years. But if you look at average global temperature, this has gone up over the last 200 years. And these things are correlated. As the number of pirates has decreased, the number of global temperature has increased. But if we stop and think about it, I don't think just because pirates are going away that the temperature is increasing. I don't think that pirates are the lack of pirates is causing the world's temperature to rise. These are probably do not cause one another. So what conclusions can we draw when things are correlated? Well, so if we have A is correlated to B in the same way that the number of pirates is correlated to the global average temperature, it could be that the first thing causes the second, or the second thing causes the first. However, it doesn't necessarily have to be that one thing causes one another. It could be that they're both caused by the same thing, but it's something else, something either seemingly unrelated or maybe something that we'd be able to see is related to both A and B. And this is the mechanism for why A and B are both related. Or it could be, as maybe the case is in our example, that the correlation is just random happenstance. Just the way that the world works, there will be lots of things that will be correlated, but won't be caused by the same thing and will not cause one another. Another common sort of either mistake or misconception that we'll have is we need to take into account what data has been reported versus what has been measured. So quite often when you survey people, you are getting a response from someone, and their response may not be accurate. And it may not be accurate for a number of reasons. Maybe they simply don't know. If, for instance, you ask someone their weight in a survey, maybe it's not accurate because they don't know their weight off the top of their head. Or it may be inaccurate because they lie. Maybe they would give you their ideal weight rather than their actual weight because this is how they perceive themselves, or this is how they want you to think of them. Or maybe they'll give you a weight that's too high. There are also loaded questions that can be asked. And here what loaded means in context is phrasing a question in such a way to try to get a particular response. And loaded questions would normally come from sources that are going to be biased. So, for example, if a political campaign was asking a poll and it asks you whether or not you'd want to vote for candidate A, or dum-dum poo-poo head candidate B, well, there's a little bit of a loaded question there when they add adjectives to another candidate. And this can happen by accident as well, and this is something that is quite funny, but quite a serious phenomenon. It's just the order in which options are given in a question can heavily influence the question. When you ask a question like, do you think that option A is more preferable or option B? Quite often, people will go with whatever you said first. So option A will be chosen more often in this case. So in order to combat that, maybe in a poll you'll ask some people the question where option A is first and option B is second, and you'll ask other people option B first and then mention option A later. So there are ways to get around this, but this is a serious consideration in statistics. One thing that can quite often happen, and this is particularly prevalent in volunteer response surveys, where you choose whether or not to respond, is we have to take into consideration non-responses. Some people will simply not respond to a survey. Either they won't take part in it, say in an internet survey on a particular website. People that don't visit the website won't take part in the survey. Or maybe they are asked these questions, but they just don't feel like answering. The reason they don't feel like answering may add to information that would be necessary in the survey. So having people not respond to a survey will influence the results. Well, there's nothing that we can do to really force people to respond in most situations. So this is a real bias that we just have to take into consideration when considering results. And then the last thing that we need to do is, which will be slightly more technical, is percentages. And percentages are often used incorrectly or unclearly. Either people just don't know quite enough mathematics and write something down that doesn't make sense, or they have used it in a way that is specifically unclear. So for example, the textbook gives an example of where someone was saying an event has been decreased, so it doesn't happen now by 400%. And you can't decrease something by 400%. If an event simply stops and goes away, every single event has stopped. That's 100% of cases have stopped. So you can't decrease something by 400%. This just doesn't make sense. And what I want to do is I want to point out when you look at the word percent, it's got two parts: percent, and cent means 100 in this context. So what percent means is per 100, and this has a very exact meaning in mathematics and statistics, and we want to use this correctly. So for example, the phrase percent of, so when I read this 6% of 1,200, this has a very exact meaning, and we can translate this directly into mathematics. So 6%, so 6 out of 100, we treat as the fraction 6 over 100. And when we say it's 6% of a number, what we're going to do is we're going to multiply. So 6 out of every 100, but the total size is 1,200. And if I've done this correctly, we should get 72. So 72 will be 6% of 1,200. So I do want to go into this in a little bit more detail. When you see, say, X percent, just like we saw before, this is going to be out of 100. So this is going to be the same as X out of 100. So percentages can be turned into fractions, and then fractions can be turned into decimals. So for instance, when I talk about 25%, this is the same thing as 25 out of 100. And if you break out a calculator, or you can do this in your head, 25 divided by 100 is going to be 0.25. And we don't necessarily have to do this middle step. So for instance, 63% is going to be the same thing as 0.63. And the common mistake that I will emphasize now, that I don't want to see happen this semester, but it will, and that's okay, is the following. if someone says 0.05%, this does not mean 50%. These are two different things. One is 0.5%, one is 50%. And it's really common to see, 0.05, this is equivalent to 50%, but 0.05% is equivalent to 0.005 as a decimal. So keep in mind this common mistake. When you see a percentage, you can turn it into a decimal, and when you see a decimal, you can turn it into a percent. Just don't add a percent on a percent. And I will stop there. If you have questions, please contact me, and I'll be very, very glad to help.